Today we're learning slope-intercept form of the equation of a line. Now the general setup for a slope-intercept form is y equals mx plus b. This is the form that we always want a line to be in when we're looking for slope and y-intercept. So when we have it in this form, m represents the slope of the line and b represents the y-intercept. So that's the easiest way to identify what the slope and the y-intercept of a line is. Now, if we're given this equation, we already have our line in slope-intercept form. And so all that's left is to identify what the slope and the y-intercept of the equation is. And so the slope is always the number attached to the x. So the slope of the line is 3. The y-intercept is the constant. That is the term that's not attached to the variable. So the y-intercept is the point 0, 3. Now, if our equation is written in standard form or general form or point-slope form, our first step is going to be to rewrite it in slope-intercept form in order to identify our slope and y-intercept. So if we're given an equation like this one, and we want to rewrite it in slope-intercept form, then we need to get y by itself. So the only thing right now keeping y from being by itself is that 3x. If we subtract it from both sides, we get y equals negative 3x plus 2. From here, it's easy to see that our slope is negative 3 and our y-intercept is 0, 2. So it's important to be able to rewrite equations in slope-intercept form. It's even more important to then use that equation to graph it. So the first step would be to rewrite this in slope-intercept form. We'd subtract 2x from both sides. That would give us y equals negative 2x plus 3. And so we can identify that the slope is negative 2 and the y-intercept is positive 3. So we can use that to graph the line. So if I take that equation, y equals negative 2x plus 3, I can start with my y-intercept, which I already know is positive 3. Then I can use my slope of negative 2 to find another point. I know that slope is rise over run, and so I could rewrite this as a fraction, negative 2 over 1, to see that the rise would be 2 and the run would be 1. And since it's negative, I need to be going downhill. So if I go with a rise of 2 spaces and a run of 1 space going downhill, I've got my next point here at 1, 1. Or I could go backwards. As I go backwards, I could go uphill, up 2 spaces, back 1. Now I have my line going through those points. And that's all it takes to graph in slope-intercept form. Let's look at example 3 from the lesson. To get from one floor to another at a library, you can take either the stairs or the escalator. You can climb the stairs at a rate of 1.75 feet per second, and the escalator rises at a rate of 2 feet per second. You have to travel a vertical distance of 28 feet. The equations model the vertical distance you have left to travel after t seconds. So for the stairs, after t seconds, the distance remaining is negative 1.75 t, that shows how much you've traveled already, plus 28, which is your starting value. For the escalator, it's d equals negative 2t plus 28. Now, since we can't ride the escalators or climb the stairs for a negative amount of time, and we can't travel a negative amount of distance, we're going to change the format of our axes to be just the positive quadrant. Let's move these functions over a little bit. So we want to graph our equations, and we're going to need a y-intercept for both equations at 28. So let's make each of our y boxes 4 spaces. And we'll make each of our x boxes 2 spaces. Okay, now let's start with our first equation. We'll use purple for that one. So that one has a y-intercept of 28 and a slope of negative 1.75. Negative 1.75 as a fraction is negative 1 3/4, and as an improper fraction is negative 7/4. So for every 4 that we go over, we're going to be going down 7 spaces. So at 4, we're going to be down 7 to 21. Let's adjust that a little bit. The next 4, we're going to be down 7 to 14. And at the next 4, we're going to be down 7 to 5. Sorry, we're going to be down 7 to 7. I knew that didn't sound right. And at the next 4, we're going to be down 7 to 0. So we see that it will take us 16 minutes to climb the stairs. Now, let's try it with the escalator. So our y-intercept is still 28. But our slope is now negative 2, which means we're going down 2 for every 1 that we go over. Or if we want to make things go a little faster, if we're going down 2 for every 1 we go over, then we're going down 8 for every 4 that we go over. So that means that at 4 we're down to 20, and at 8 we're down to 12, and at 12 we're down to 4, which means that at 14 we'd be at 0. So the time we spend on the escalator is only 14 minutes, whereas the time we spend on the stairs is 16 minutes. So we've graphed the equation and we find that we save only 2 seconds by using the escalator. Alright, now one thing we notice when we're graphing lines is that if we graph multiple lines on a page, we'll see that sometimes we have lines that intersect, sometimes we don't have lines that intersect. Now, the lines that never intersect we call parallel. And parallel lines always have the same slope. So, if we're given 3 lines, as we are in example 5, and we want to determine which of those lines, if any, are parallel, we need to know what the slopes are. Now, instead of just using the slope equation, I'm actually just going to count rise over run. So, between these 2 points on the blue line, on line A, the slope of line A has a rise of 1 unit, and each y box represents 1 unit, so I want to be careful that when I count one box that I know exactly how many units that is. So that's up 1 unit and over 3 units, because each x unit is 3 units, or each x box is 1 unit. So I have a slope for A of 1 over 3. When I look at B, and I look between the 2 points, okay, I have a rise of 2 units, run of 5 units. So the slope for B is 2/5. When I look at C, between these 2 points, I have a rise of 2 units and a run of 6 units, which is 2/6, but that reduces to 1/3. So we see that since lines A and C have the same slope, they're parallel. And we have a symbol for that. We could say A is parallel, looks almost like an 11, to C. So that's how we determine if lines are parallel. Now, I want you to take 2 equations and determine if their lines are parallel by finding their slopes. One of them will be in slope-intercept form, and the other one is going to be in standard form. So take a second, figure out what their slopes are, and determine if they're parallel, and then unpause the video and check to see if you're right. Okay, so the slope for the first equation is -3. That one's pretty easy to find because it's in slope-intercept form. For the second one, we need to solve for y to determine if it has the same slope. So we subtract 6x from both sides, and we have 2y equals -6x plus 7. But then to complete the process, we need to divide both sides by 2. Which gives us y equals -3x plus 7 over 2. And so that also has a slope of -3. So yes, these lines are parallel. Okay, if you have any questions, feel free to ask, or you can go back and watch the video if you need something clarified. Otherwise, you can move on to your homework.